This question is about amines. Give an equation for the preparation of 1,6-diaminohexane by the reaction of 1,6-dibromohexane with an excess of ammonia. So the first thing to do is think about the structures. So we're trying to form 1,6-diaminohexane. So on the end of our hexane chain, we want to put an amine group at each end, 1 and 6. And we want to form it from 1,6-dibromo . 1, 2, 3, 4, 5, 6, and put a Br on each end. And it's with an excess of ammonia, so that's quite important. So let's just have a look. We've got ammonia, we know is NH3. And then we've got a Br at each end of a CH2 chain that's got 6 CH2s. That's each one of these points, CH2, 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 CH2. And we're going to form the diamine, which we can see has got an amine group at each end of the chain. And then we're looking at it and we're thinking, well, we've kind of swapped off the Brs for an NH2, which would leave us with HBr, but you need to be careful because HBr is acidic and ammonia is basic, and so with an excess of ammonia, we'd form the salt, NH4Br. So 2 Brs fell off, so we'd form 2 of those, which means in total we need 4 ammonias to do that. Complete the mechanism for the reaction of ammonia with 6-bromohexylamine to form 1,6-diaminohexane. So 1,6-diaminohexane again. But this time we've got 1 bromo and 1 amine group. So the first thing we need to do is put the lone pair on our nucleophile. Our nucleophile attacks the carbon that is delta positive, which is the carbon with the bromine attached, and we can see that the bromine is kicked out. So at that point, we can copy this chain to there, and we've added an NH3 to this carbon, and we've lost a bromide ion. Now, because the nitrogen has given away electrons and was neutral, it becomes positive. So then we're going to lose a proton. That proton will go to an ammonia in the mixture, but we don't need to show that in our mechanism. And then we've got a H+. Then it says, suggest the structure of a cyclic secondary amine that can be formed as a byproduct. So if we think about our structure again, which is just some working out here, I'll cross through this in a minute. There's a lone pair on this nitrogen as well, so if this were to attack this point and kick out the bromine, then this nitrogen would be attached to a ring that had 6 carbons, but the nitrogen would then become part of the ring, so we'd end up with 7 sides. So the nitrogen was attached to number 1, 2, 3, so it'd be 6, 5, 4. Just try and draw that a tiny bit clearer. That 4 and a 3, and that nitrogen would lose 1 hydrogen, so it would end up with 1 left because it had 2. So a 7-membered ring, and we'll get rid of our working out. One 6-diaminohexane can also be formed in a 2-stage synthesis starting from 1,4-dibromobutane. So we're increasing the carbon chain length here. So our first thing would be we'd need to use KCN because we need to use something with a cyanide ion in order to increase the number of carbons in the chain. And that's in aqueous ethanol. And then we'd like to reduce the So that would give us some nitriles on the end, like that. Oops, I've added an extra carbon there. There we go. And then we're going to reduce those with hydrogen and a nickel catalyst. The next thing asks us to explain why 3-amino pentane is a stronger base than ammonia. So this is about the alkyl group having a positive inductive effect and increasing the electron density on the nitrogen, which then means that the lone pair on the nitrogen is more able to accept a proton, and that's the definition of a base. So the alkyl group in 3-amino pentane has a positive inductive effect, increasing the electron density on nitrogen, making the lone pair on nitrogen more able to accept H+, a proton. That makes it a stronger base. Justify the statement that there are no chiral centres in 3-amino pentane. So this is 3-amino pentane. To be a chiral centre, you need to have a carbon with 4 different groups, and the only one that we might be tempted to think of having 4 different groups is this central one, but you can see that the molecule is symmetrical around that point and has 2 ethyl groups. So there are no C atoms with 4 different groups attached because it's a symmetrical molecule.